Hey, the world's smallest lab, K4ZEP. Decided to take a break from Gunderson for a day or two and just play around a little bit with the Super Joule 3 2.0 shown by Laser Saber and Peanut Butter 291 on YouTube. Nobody seems to show waveforms and stuff, and to me that's where the whole thing is at. So I just threw together a quick one here. It's there's 3 amp Radio Shack transformer, 110 to 12, center tapped at 6, 3055 LED in series with another diode, gives about a 3.5 volt drop there. 330 ohm resistor in series with a 10K pot, so I can vary the drive on the base. And I have a capacitance substitution box here to don't really want to say tune the output, because it really doesn't tune the output, it just modifies the waveform slightly. And a 160 watt LED bulb. And right now I'm operating at about 3.6 volts at 0.22 amps. 2 times 3, about 0.7 tenths of a watt, give or take. And the most interesting thing I found about this whole circuit, and on this circuit here, the upper trace is a collector on a 5 volt scale. The bottom trace is the output on a 20 volt scale. So you can see right now, even at 3.5 volts in, it's 20, 40, 60. Actually, measuring peak to peak is 99.2 volts, peak to peak, give or take. And let me turn the run stop back on, because this thing is only running at 47 hertz. And now the most interesting thing I found is, and I'll show you here, as we run the voltage up, voltage is on the bottom, current's on the top, and we go on up, the output current doesn't seem to change. Not that much. The frequency does change a little bit. It went up to 69 hertz now. And now the peak to peak is almost 220 volts. Peak to peak going into this bulb. And this bulb is just as bright as heck now. So we're drawing at a quarter of amp at 12 volts. We're drawing about 3 watts right now into this bulb. The waveform on the output is interesting in that it's bidirectional. If you look at the switching on the top, let's draw it back down a little bit so we can see it. It switches in phase with the output. Duty cycle looks to be about 20%. Right now at 8 volts it's right at about 60 hertz. What can I say? If this thing will drive 8 or 10 of these LEDs at this same power, it's doing very well. But I just wanted to see the waveforms of what was going on, and now to show you something here, I'm going to switch in. I am across the load side, trying to tune the load side, and now there's the current coming from the power supply, and if I switch in a 1 microfarad, it drops at 10 milliamps. If I put in 0.1 microfarad, it really doesn't change anything here. Switching in and out this capacitance, tuning is, I think you're chasing your tail on the tuning gang. The frequencies and the impedances here and the capacitance is shown, I don't believe has much to do with tuning, but that's just my personal opinion. But I can switch in 2 microfarad and it slows the frequency down somewhat and lowers the output just a little bit, because the duty cycle of course is less. You can see switching in 2 microfarad across that output. Putting it across the input side doesn't really do anything. It can start some ringing going on in there, but capacitors just take it out of the circuit and it works just fine without it. And in fact, as I adjust the drive, base drive, I can, as I start lowering the resistance, the current goes up Woo, and it jumps, all of a sudden it jumps to twice the current, and which I don't like. And we can turn the voltage back down here and get it to drop back into the other mode of the low current mode. And let's turn the resistance back up. In fact, it almost, now it's jumping back in and out of that other mode right now. Yeah, there's a half an amp at 9 volts, and you can see, you can't tell because the automatic gain on this camera overrides it, but it's considerably bright. There's 4 watts input, and it's up to 147 hertz now, and you can see the waveform is not the waveform that I want. Let's go back here, bringing the voltage back up 6 volts. Bring the time base in. We're back down to the 28 milliamps. So there is 2 modes where this thing oscillates funky, and the low current range is the one that really is what we want. And there is 12 volts at a 1/4 amp, which is 3 watts. And that bulb is bright. It's not 100% lit, but it is showing almost 220 volts peak to peak across that bulb, although it's a very short waveform. But it does trigger those LEDs in there and makes it appear to be very light. I have to get back from the light. It's not blinking or carrying on. It's just the camera doing this. It's just very, very bright. Coming back down again, down to, this thing will run down to, I'm down to 2 volts here. And it's still strange, actually the current goes up at the lower frequencies. You can see what the waveform looks like, and as we come up, the waveform sharpens up, and of course the bulb gets bright. But the most important thing is when it's operating in this low current mode, the output voltage is considerably higher than 110 volt. I could calculate the RMS, 200 to 100.7, it's about 70 or 80 volts RMS, which is not exactly full power, but for all practical purposes, if this thing will drive 10 LED lamps like this, these 60-watt lamps like this at 4 watts, that's saying something. So anyway, I'm impressed by the circuit. I'm not impressed by the tuning. It doesn't do really anything. It just shifts frequencies around. It does not resonate the circuit. It just doesn't do it. Anyway, interesting. Wanted to show folks what the waveforms look like. This has been K4ZEP, and I'm gone.